Good day. Welcome, guys, again. Today we're gonna look at lesson number 2, that is digestion in non-ruminants versus ruminants. I hope you managed to download the first lesson on alimentary canals and that you were able to watch it over and over again. That's the beauty of it. You download it once and then you can watch it as many times as possible until you get a clearer understanding. And now we're going to look at digestion. And as usual, we're going to start looking at the mind map. We're going to first look at the digestion in non-ruminants, digestion in ruminants, and digestion in the ruminant. And then here, the intake of feed, also difference between mechanical and chemical digestion processes, mechanical chewing and chemical by enzymes. You know that. And then we're going to look at the functions of the four glands, that is salivary, liver, pancreas, and intestinal glands. These glands are called accessory glands because they are not part of the alimentary canal, but they assist in the digestion that takes place in the alimentary canal by secreting their digestive, their juices or digestive juices in the alimentary canal. All right. Looking at the ruminants, you need to know rumination, regurgitation, and peristalsis. All those concepts. Also look at the intake of food and the chewing of the cud, the difference between size and functionality of the four compartments. In the rumen, gonna look at the rumen microbes that are known as single-celled organisms. They've got only one cell, and they are located within reticulum and rumen only. Also, you should be able to know the types of rumen microbes, your bacteria, protozoa, and their specific functions within of these bacteria. That is cellulitic, those that digest cellulose, proteolytic, those that digest proteins, and amylolytic, carbohydrates. You should also be able to describe the requirements for normal functioning of. So when they say describe, you're not just gonna say temperature. You must say suitable temperature of maybe 37 to 40 degrees. You should be able to describe it, not just to list. Name and the functions. You know the functions of microorganisms, you need to know them. And also you should be able to explain the absorption of food in the rumen. And there's 4 ways: directly, by osmosis, or by diffusion, and lastly by active transport. All right. Now that we're through with our mind map, we know what we're gonna look at. Let's start with the terminology. And I said, guys, you either cover this side and look only at the terms and try to define the terms, or you cover this side, look at the description and try read the description and align it with the term. That is very important. All right, let's look at the definition. Movement of dissolved food into the cells of the body. That one is not absorption. If food moves into the cells, that is assimilation. I think it's just an error there. If it's absorption, it's movement of this food into the blood, bloodstream. All right. The enzyme that converts starch to maltose is amylase. Effect of conversion: starch, amylolytic, we said so. This yellow beta alkaline liquid in the liver, it's bile, and its function is to emulsify fats, among others. The chewed round food mixed with saliva, it's bolus, and that's how it travels through peristalsis. Bacteria and enzymes capable of hydrolyzing cellulose, those are cellulitic, we said so. Chemical reactions by digestive enzymes, so the difference between chemical is chemical reactions done by enzymes. Partly digested food from rumen back to the mouth for chewing, we call that one cud. Nutrients in the digestive system diffuse from place of high concentration to low concentration, we call it diffusion because it's nutrients. If it was water instead of nutrients, we're gonna say it's osmosis. So that's the difference between the two. Mechanical and chemical breakdown of food is digestion. Chemical breakdown of food substances by microorganisms in the rumen, we call that fermentation. Fats broken down into small droplets, emulsification. Enzyme that converts trypsinogen to trypsin, enterokinase, found in the succus entericus. All right, we continue with the terminology. It's very important, guys. We're not wasting time here. It is very important to know the subject of the language of the subject. Eyes of Langerhans, these are irregular clusters of endocrine cells. Once we mention endocrine, you must know that those cells secrete hormones, in this case hormone insulin. But as well, we know that pancreas also has another function, which is an exocrine function, that is the one of secreting digestive juices, which is the pancreatic juice. So the pancreas can play both roles, endocrine and exocrine function. Enzyme involved in the digestion of fat, it's what? Lipids, and then you just change, put in ACE there. So lipase, it breaks fat into fatty acids and glycerol, and it's the only enzyme, and it is assisted by bile. We have already covered osmosis. Enzymes that break proteins to peptides, we said it's pepsin and trypsin. So it's easy to remember the enzymes that digest protein because they end with sin, suffix, it's sin. All right. So but as a Christian, I see sin as sin, and I just want to declare this, that if you don't get rid of sin, sin will get rid of you unless you accept Jesus Christ. All right. Wave-like contractions that move food down along the digestive tract, peristalsis. Breakdown of proteins into simpler compounds, proteolytic, because it's breaking protein. Enzymes that changes soluble carcinogen of milk into insoluble casein, it's renin, that's milk curdling. Wave-like contractions that move food upwards, so it's backwards to the mouth, it's retroperistalsis, vomiting or regurgitation in terms of ruminants. And then swallowing is when food passes through into esophagus and stomach. Then looking at digestion and nutrient absorption, we know that digestion, it's either it's mechanical or it's chemical through this enzyme amylase, which is found in the saliva. Saliva is secreted by salivary glands, and we know that there are 3 salivary glands, parotid below the ear, sublingual, lingual for tongue, ne? Sublingual below the tongue, and submandibular below the jaw. All right. Okay. So these salivary glands, they secrete saliva. In the saliva, you find salts, proteins, and this enzyme amylase, which breaks starch to maltose. And the pH of amylase is neutral. So saliva is neutral or just slightly alkaline. So the stomach serves as a reservoir for food for digestion. And digestion also, it happens in the stomach. So if this is the stomach, there is the esophagus. So we know that in the stomach, there's what we call gastric juice. Gastric is another name for stomach. So it's stomach juice. Stomach juice contains what? Hydrochloric acid. This substance which makes the stomach to be acidic. Even when the food goes back to the, when you vomit, you can feel the acid. And then also there's 2 enzymes, pepsin and renin. Renin is the one that we said it's responsible for milk curdling. So you can see that they say this pepsin is a protein splitting enzyme, and also this pepsin, it needs a pH of about 2. All right, and looking at the processes, the 5 processes of digestion. The first one is ingestion, whereby food is ingested in the mouth, intake, and then whilst in the mouth, then the digestion starts, saliva amylase, and then in the stomach, and then down to the small intestines, where there are a lot of enzymes, and then this is the main organ of absorption. As you can see here, that these substances then will get absorbed into the bloodstream. That's number 3. And then when these food nutrients, these end products, now travel to the body cells, we call that one assimilation, as you can remember that I was correcting that. So absorption is when these end products leave the small intestine to the bloodstream. Then from the bloodstream to the cells of the body, we call that assimilation. And then any food that has not been digested, that is your lignin, the crude fiber, the cellulose, and the hemicellulose. This is that is carbohydrate that's difficult to digest, is ingested in the feces. Okay, see you later.